Thank you very much for this warm welcome. It's always a pleasure to be here. This is my 6th time here, but I only missed 2. It's also my 3rd time on stage. I hope it will be okay for this time. Yeah, let's start. What is a side effect? So I don't know if you ask yourself this question. I don't know who does. Maybe we take it for granted. But if we were to think about it, we might think it's like the interaction with the real world, right? It's something that goes outside and comes back. And that makes things useful, right? We get useful stuff from outside, we get it inside, and so on. But also, you might know this, it's a bug waiting to happen. So we saw in other previous presentations, side effects, caching, stuff like that, or stuff that can go wrong. And I think we've all been there, and we can say that effects are a necessary evil. We need them, we don't like them, but I think we can manage them. So, hi, my name is Bogdan, as I was introduced. I work at Hootsuite. I'm also from Bucharest, as Dan is. And you can find me on social, on most places as Saboko. And today I'm going to talk about this subject of managed effects. I'm going to try to explain you what they are, and I'm going to try to make you see that they are powerful. So I hope I can convince you of that. Let's talk about side effects. And more specifically, in this talk, we'll talk about UI side effects. And as we all know from the current modern frameworks, we have this famous formula that UI is a function of state. So it's very nice, right? On paper, it looks great. Only that this is not the whole story, right? It seems like very pure and abstract, but it's an illusion. Of course, we don't have something like that because we'll see why, we know. We have another formula, which is also very, very famous, which is that given a state, we get an action, and then we go to another state. So we know this is a reducer, basically. It's in different libraries. It's all over. It's a very common pattern. And of course, what are the effects? I mean, we get these very nice things on paper, but it's kind of a little lying. Where are the effects in the formula? And where are the effects in any formula, actually? Because we don't really see them. And that's for a very good reason, because effects and formulas are like in different worlds. Because on the one hand, effects are imperative. You just tell the computer how to do things. You instruct it, you say, OK, you set timeout, when you're done, dispatch. But this actually runs, right? You cannot really control how this runs. And on the other hand, we have formulas which are more declarative. And you tell the computer what you want, and it figures out how to do it. So to bridge this gap, because it's quite a big gap here, and to have this mouse out, we're going to basically use this technique that we have here, and I was trying to explain about is the managed effects. And how we do this is by taking this imperative code and try to make it somehow declarative. And we can turn this like in an instruction. It's basically, we say, OK, we have a delay. And what to do when we are done, we just dispatch this action to close the notification toast. And it takes 1 second. So basically, you can see it's very, very clear, right? You can explain to a human. You can explain to an agent. You can explain to the computer. And at some point, something will execute this, right? We don't know yet, but we'll see. But how to do this in the UI, right? We get this very nice declarative thing, but we don't really use it yet. So for that, we can go back to the famous reducer formula and try to extend it a little, just that it gets, besides the state, it also gets a command. So, OK, bear with me. I'll get you. It might sound very confusing right now, so let's get an example. If you are logged out, let's say you have a very simple state, and you get the login action, you get basically loading because you don't have anything yet, right? It's a spinner, we all know, and you have to somehow log in and get the user, right? So for that, you can also produce a command. And in this case, it's a very generic command. It's a promise. You get this function, and when it's done, when it resolves, you get the action logged in, which somehow gets to the reducer back. And of course, this is nothing too crazy, right? It's OK. But this kind of changes our mental model, right? It's quite foreign from what we usually do, right? We are used to another way of thinking. And that way of thinking is you have this UI that triggers actions, and the reducer handles them, and then refreshes the UI. This is basically the idea. It might not have reducers, but it's kind of the same thing, right? And of course, these are these hidden. Who likes use effect? Use effect? No? OK. Me neither. It's very hard to use it, right? Who likes tongues? Anybody remember tongues? OK. Oh, cool. We have some Redux. Yeah, we still use Redux. Dan was saying before that if you get with Redux, it's hard to get stuck. It's easy to get stuck and hard to get out. So we all know. But again, you see that these things don't really belong there. They're kind of sneaking inside. They're not really part of this diagram. So in order to do that, the first thing we need to do is take these things that are all over the place and move them to something called the executor, which is a special component. It's somewhere outside. And this executor basically takes a command that the reducer produces. It executes it. Somehow, it's pretty generic. And then it sends an action back to the reducer. So basically, now we have these two parts. We are used to getting actions only from the UI. Now we also get actions from the outside. So you can think of it as a double cycle or something like that. And it's basically all actions now. It's quite symmetric and quite easy to understand in some way if you can get used to this way of thinking. And this model brings us some powers. You might think, you might not know why, but we'll get to this in a second. And the first power is purity. So before it was an illusion, now we try to make it real, right? And we have this thing going, OK. We have this thing that I just showed, and this basically introduces some borders, some purity borders. So on the outside, we have things that are impure. We have user interaction on the left side, yeah. On that side. We have this user interaction. We are rendering the DOM. We are updating the DOM, and all this stuff. We remember jQuery, right? That nice interface and nice, very easy to use. But that was still imperative. But then now, basically, kind of all the code that we write is declarative. So I say we fix that. It's fine. We can go to the executor part, which is the new part that basically handles your outside world things. It's like we can be network calls. It can be timeouts. It can be your home. If you're using, like, I don't know, a smart home or something, you can use that to turn out the lights, anything. And in the middle, we're stuck. We're getting this nice thing that the reducer is now pure. So basically, it's just state and actions and commands. That's it. And this also introduces this test separation. So because of that, for the UI, you can have like visual regression and some store interaction is more a decoupled way of testing. The big part now goes on the executor. The executor is like where the complicated stuff happens with, I don't know. It can have very complex tests with mocks. They're usually slow. We know. We kind of do that already, but we do it with all the code. And now we try to push that as far as we can in the executor. But what is nice is that the executor has to handle like very general commands. It's like you handle promise, you handle delays. And if you write those tests, they kind of don't change because promises are promises. So we have this thing in the middle that leaves us with the reducer tests, which are now pure. And even if they change frequently, they run fast and they are easy to understand, so it's all good. Of course, we all know that these are more like unit tests, and they don't tell the whole story because we still might have problem integrating these things. So that's why we can have integration tests, right? It's a good practice to also have like a higher level tests. And we can also use tools like Storybook to develop our components in isolation. So it's kind of the same thing. And we would like to be able to control in some way, because if we let the executor just run, we didn't really gain anything. So we can have this controlled executor. And I'm going to leave you with this slide a little just to drink some water. And to understand how this works, we can get a little demo. And I have a interesting application here. It's like we have a startup idea. We want to disrupt calculators. So we make a remote calculator, which is a very good idea for a startup. And you see it works. Not that fast, but it's the first. It's an MVP. So we can work on that. It can add numbers and double them. It's very good. And we are very happy. Of course, we vibe coded this in one day. So that's how we do that right now. And we have a startup, and we release it, and we have users. And in 2 days, we get this. Oh, OK. Seems like our QA, we kind of offloaded everything to the agent. So it did a really a good QA job. So we get this thing that, OK, try to understand. Rapidly clicking, increment, and double results in 3. Interesting. So our math must be wrong, right? Or no? Let's see. We try to reproduce this. We try to, sorry. Oh, OK. Seems that we're pretty quick to do this, and we try to reproduce it, and we think, what could go wrong here? What's going on? And maybe we ask the agent or whatever, we ask our colleagues. Maybe we still have people to work with, not only agents. And we remember something, how we started. We started with this thing. It's like, it's a bug waiting to happen, and it just happened. And it's not any bug. It's a very, very, it's our friend, a race condition bug. And I know, we all know, it's very easy to catch. It's very easy to reproduce. It's like you just press a button and it happens. OK, not OK. But we have this executor thing. And as I said before, you can control the execution. So if you can control the execution, you basically can be able to stop time. So just think about it like you'll see in a minute. But it's something, it gives you much more control because you don't run the promise right away. You give it to the executor. So you just handle it. And that gives you very powerful tools, which is, we have this, actually that's the power, yeah, we have control. And we get this new tool, which is like a dev tool. Also vibe coded, of course, it's how we do it. And basically you can just see the commands. OK, so I incremented, nothing happens, it's still loading, and we stopped. So we stopped the time. It's magic. And then when we choose to, when we feel like we can go get a coffee, whatever, we say, OK, let's get back, resolve it. Nice. We kind of play the server here, right? we say, OK, I want to be the server. It's like a game. And then we double, we resolve, we reset. That's also on the server, of course. We don't want to. We have a good application here. It resets on the server. And then we try to replicate. We remember why we started this, right? We say, OK, we quickly press these buttons. But now it doesn't matter, because they're both here. They're both pending. And we can choose what to resolve first. It's like we're simulating on the server a slow response, or like the response are mixed. And we resolve the double first, and then the increment. And OK, we got a bug, right? Sometimes this might feel like very, very good, because we all have these experiences where we try to debug some very hard to catch bug. And now it's like, OK, we can do it whenever we want. We can maybe add tests for this thing, because we can use this control power to use it in the tests as well. And this also gives us a new power, which is tracing. So as you saw, we have like this list of commands and then actions. And these things are serializable. It's a hard word. These things are easy to trace, like to turn into data and to send to the server. Is like observability and all that stuff, which is good for the front end, because we don't really do that much, right? And we can actually use this power. Maybe not in the best way, but for this demo, it's fine. We add a new feature. We have a new feature here. So it's a new feature that when the user presses something, it gets a report bug. That might not be very good for the user trust in us. It's like, whatever you do, you might have a bug. It's not the best, but at least we show them that we care, right? We are there with them. We don't let them make screenshots and stuff like that. So the user can just try to reproduce the bug. It's pretty hard, you know. OK. And then they just can report the bug. So like they have the same tracing that we had before. They might not really care about this. OK, this is just to show the demo. But we care, right? We care. Sorry, no, not yet. We care about that log, right? We want to see what happened in real time. And we can take that log, get it locally, run it on our computer, replay it, see what happens, and try to find the bug. And this is also, yeah, it's powerful, right? But we had the race condition, right? We found it, and this is how it looks like. It's not a big deal. I mean, it is, but it's not hard to understand why it happened. I don't know how we missed it in the first place. Maybe the agent, didn't really know all the things. Increment starts, double starts, then increment, it's taking longer, so the double ends first. We get swap the commands, and we try to fix it, right? And we remember in school, we had this data structures thing, and Dan actually already used this. And you might remember what data structure he used in his presentation. OK, it's a queue. So he kind of explained it, but I'll go a little bit on it as well. We basically use a queue. We push these commands on the same queue. You see that it's called op, like operation. So we make sure that they resolve in order. We don't want to start double until we increment. We just queue them one after the other. So that way, we make sure that it's what we expect, right? The order of the operation matters, so we make sure it's in order. And imagine using tongues and try to implement this queue. And of course, 10-stack query might fix this. It's a great library, and it has a lot of abstractions. And it also makes code more declarative, so that's very good. But if you are stuck with Redux, like we are, for example, it's hard. And then you think, OK, we have this executor stuff that we talked about. What if we just pass it to them, the executor things team? What if we pass this to this executor component and just let it handle it, right? It turns out that it's not that complicated. We are going to still use the same pattern, which is commands, and it's also declarative. It's just an object, basically. And this might be a little bit more complicated to think about, but it's just basically a command inside a command. It's not that much complicated. You can call it maybe a higher order command. And that gives us this, this new way of thinking. So we update the executor to support queues, and we update the dev tools to also show them. And now when we, it's the same for the first request. We see it's pending. And for the second one, it's queued, right? We cannot resolve it because it didn't start yet. So when we're ready, again, drink a coffee, have some Netflix, whatever, we come back and resolve. And now, only now, the queue is advancing to the double. And we resolve the double as well, and everything is fine. There's no bug anymore. We make sure that the bug is not reproducible. It cannot exist, at least this bug. Maybe we have others. And we deploy to production again. It's good. We can have multiple. We quickly click, and you see that it kind of waits a little. And yeah, it's all good. We deploy again. We're happy. We wait for users. Again, we hope for to have not other bugs. And yeah, this is the fourth power. And this power is composition, which is very important. And if we take this example, we take the queue. But we also can have other examples. You can think of all, command.all, which it's similar to promise.all, except that, as we remember, this is declarative, so this doesn't run at once, as the promise does. It's going to be sent to the executor, which is going to run all the commands in parallel. Then it's going to resolve them when they come. This is not very complicated. We have the race composition, which takes two commands. When the first one resolves, the other is ignored. So if you think you can use for timeouts, you send a request to the backend. You also start a timer for 5 seconds. If the response doesn't come back in 5 seconds, you just time out. Otherwise, you ignore the timeout, so it's fine. And we also have debounced, which I guess you're familiar. We make sure that we don't send unnecessary commands to the backend. So if we send the same commands 3 times in a row in a short time window, we make sure that we only send the last one, so we don't throttle, we don't overload the server. And I just want to tell you that this whole thing is totally not production ready. So all you saw, like the library and the demos, as I said, pipe coded, so it's fine. But why did I do them then? You might wonder. It was just, I tried to do like the minimum thing, just to showcase this concept. And in JavaScript, there's nothing really like this. But there still are things that you can use today, and are very much more, of course, very mature, and they are in production. And you can, for example, you can use Xstate and Xstate Store. I think you're familiar. It's like Xstate is more for state machines, and Xstate Store is like a lighter, more classical store. But they both have some mechanism to actually replicate this commands thing. So you can enqueue some commands, and you're going to tell it later how to execute them. So it's basically the same idea in another fashion. On the other hand, we have effect.ts. Maybe you heard of it. It's kind of got a lot of traction lately. It's more on the backend side, so if you're using Node, you might have heard. It's more probably that you've heard of it. This is the whole ecosystem for managed effects, right? You have composition there, you have error handling, you have dependencies management in the effect. It's pretty wild. It's actually like you have you don't no longer have Node.js apps, you have effect app. So, but it's worth checking out. It's at least like to make an idea of what's there. And if you feel like you want to really take an adventure, you can go into Elm language, which is not JavaScript. It's another language. It compiles to JavaScript, but it's a functional programming language. It's sort of Haskell, but simplified. So it's like idiomatic. It's like idiot-proof, as they just said. It doesn't get into all those fancy, complicated stuff that Haskell does. But it implements this. It's called the Elm architecture, and this is basically what I've just presented, only that it's in Elm. So if you want to try that out, I recommend. It's really interesting. And there is also an implementation of the Elm architecture in JavaScript, but it's tied to Redux, and I didn't really use it that much. So, but still, there is, if you want to try it. Redux Loop, it's called. All good. All good, right? Okay. So these things are nice, right? We have effects, we can control them, we have all these possibilities to have dev tools that are very, very good. But the question is, should I use managed effects? We have this, but, and you might guess, but the answer is it depends, of course. And when should I use managed effects more exactly? And of course, it's not this demo application that I've just made. For that, in the first place, it shouldn't exist. But if it did, you wouldn't use managed effects for that. It's just for the demo. But if you keep adding features to it, and it gets into this very complex state that your effects depends on the current state, so you can have like very complex logic that you decide what commands to send based on what state you are in, then it might be worth it. That also ties to some complex effect orchestration that you want to make sure that you have control over them and you can understand how they work. So like a more higher level and declarative level. And also that feature that might be useful, like also related, you can get time travel debugging. Even better than we do today. We have this thing in DevTools. We have time travel debugging, but the side effects are not really covered here. So we get this upgrade to the current time travel debugging, and of course, audit logs if we want to do that. Of course, if we want to use it, there are trade-offs, as for everything. And the biggest one is that it's a new mental model, as I said. It can be hard to think in this way. It might take a while. The team might not be ready. They might be reluctant. There's also an extra abstraction layer, which you no longer have direct server access. You have to pass to this executor. So it might be harder to get through it, and you have to take this in mind. And as I said about teams, I don't know for you, but from my experience, teams, when they hear something even remotely related to functional programming, they kind of just run away and say, no, monads, no, we don't want to see that. Yeah, but if you don't tell them this is functional programming thing, they say, effects. We manage effects. It's nothing fancy. But if we take these trade-offs and we can make sure to handle them and be aware of them, we go to the powers. And to summarize, we have the purity, we have the control, we have the tracing, and we have the composition. And these are the powers of managed effects. And thank you.